Have you ever just stopped right now and thought, what is this? This specific blink of an eye, this very breath, it feels so intensely real, so separate from everything else, but is it really? Today, we're tumbling down the rabbit hole of now, what it means, and why it feels so darn special. And our guide for this journey, it's the brilliant mind of Sabine Hossenfelder and her book, Existential Physics.
Exactly. And we'll be pulling threads from, well, what might seem like pretty different corners of physics. Think Einstein's relativity, thermodynamics, which people often misunderstand, I think, and even a little peek into how our brains actually process time.
It's all connected.
It seems to be.
Yeah.
And it all paints a surprisingly nuanced picture of this moment we call now.
Okay, so our mission, should you choose to keep listening, and trust me, you probably will, is to get to the bottom of this feeling of presence. Why does now feel so unique when the universe, well, according to physics, might not treat it any differently than any other moment? Okay, so let's dive straight into something that throws a cosmic-sized wrench into our everyday assumptions. The illusion of simultaneity.
Yeah, this is where things get really weird fast. What's truly mind-bending is how Einstein's special relativity showed that our intuitive grasp of time.
Like a single now for everyone.
Exactly that. This idea of a single shared now happening for everyone simultaneously, it's actually just, well, a comfortable illusion.
Right. Hossenfelder walks us through this with a classic thought experiment. Imagine you and your friend Sue floating out in space, right? Both watching laser beams hit some mirrors.
Okay.
Now, if you're moving relative to Sue, you'll actually see those laser pulses hitting her mirrors at slightly different times than she does.
And she'd see the same thing looking at your setup.
Yeah. So whose clock is right? Whose now is the real now?
And that's the kicker. The truly revolutionary insight is that neither perspective is inherently more correct. Special relativity tells us that the very definition of two events happening at the same time, it depends entirely on your frame of reference.
Or motion.
Your state of motion, exactly. It's relative.
Yeah.
So the core takeaway here is that this idea of a universal now for everyone, everywhere in the universe, it just doesn't hold up.
See, you might think this is just some abstract, brain exercise.
Fairly theoretical.
Yeah, but it has very tangible effects, doesn't it? It's not just philosophical pillow talk.
Absolutely not. Just think about the GPS system we all rely on every day. Those satellites are whizzing around Earth at thousands of miles per hour, and they're in a slightly weaker gravitational field than we are down here.
Okay.
Both of those things, speed and gravity, they cause time to tick ever so slightly differently for the satellites compared to clocks on the ground.
Tiny differences, I assume?
Oh, minuscule.
Yeah.
But your phone's GPS receiver has to constantly account for these differences to give you accurate directions. If it didn't, well, the errors would add up fast. You'd be way off course pretty quickly.
So my ability to find that coffee shop I like is actual proof that now isn't the same everywhere.
In a way, yes. It's practical proof that time flows differently depending on motion and gravity, which directly undermines the idea of a single universal now.
That's a fantastic way to put it. And Hossenfelder makes it clear this isn't just about our little earthbound tech. This relativity of now, it applies to any two events, no matter how far apart in the cosmos.
Anywhere in the universe.
It makes you feel like the universe is this incredibly interconnected yet strangely personal experience.
Yeah, exactly. And if we take that idea and zoom out, like way out to the grandest scale, it leads us to a concept that can feel a bit like stepping into science fiction. The block universe.
Okay, I'm intrigued. And maybe slightly terrified. Unpack block universe for me.
Well, at its heart, the block universe is kind of a direct consequence of what we were just talking about, the relativity of simultaneity. If there's no single objective now slicing through the cosmos, then it suggests that all moments in time, past, present, and future, they all exist. sort of equally within this four-dimensional fabric of space-time. It's all just
Hmm.
there.
So it's less like a flowing river of time and
Yeah,
more like maybe a giant static photograph where every single moment is already captured.
that's a pretty helpful way to visualize
Right.
it, yeah. Hossenfelder uses this analogy. I think it was some comedian John Lloyd,
Oh, yeah.
who likened time to a landscape.
Hmm.
Just because you're not currently standing in, say, Paris doesn't mean Paris doesn't exist, right?
They said.
Similarly, just because we aren't experiencing a particular moment in time yesterday or next Tuesday doesn't mean it's not a real part of this four-dimensional block. The profound takeaway here, or at least the argument, is that our past isn't just a memory. It's just as real as this very moment existing in the fabric of space-time, and maybe the future, too.
Okay, here's where my brain does a little stutter step. The idea that my awkward teenage years, that amazing concert I went to last year,
Hey.
even my future self trying to figure out how to work some new gadget,
All of it.
all of it exists simultaneously in this block universe. It's
Yeah.
wow. It's strangely comforting and deeply unsettling at the same time.
It definitely clashes with our gut feeling, our intuitive sense of a flowing present, doesn't it? If all times are equally real, what creates this powerful feeling we have of being anchored in this specific now?
Yeah, where does that come from?
And this naturally leads us to another really interesting idea, time reversibility in the laws of physics.
Time reversibility. Sounds like something I wish applied to my last attempt at baking bread. It did not go well. Tell me more.
Well, the fundamental equations that govern how physical systems evolve, think mechanics, electromagnetism, they are by and large time reversible. Imagine a video of, say, a perfect collision between two billiard balls with no friction or anything.
Okay.
If you ran that video backward, the motion would still perfectly obey the laws of physics. The reverse collision looks just as physically plausible as the forward one.
So wait, at the most basic level, the universe doesn't inherently have a forward direction of time built into its rules.
Largely no, which feels completely counterintuitive, like you said, because our experience is full of things that only go one way.
Right. Spilled milk doesn't unspill itself. Eggs don't magically reassemble after they break.
Exactly. Our everyday lives are absolutely filled with processes that have a clear direction. Ice melts in a warm room, but the water doesn't spontaneously freeze back into an ice cube. We age, we don't get younger,
Unfortunately.
unfortunately.
Yeah.
So why this huge difference between the apparent time symmetry of the microscopic laws and the obvious time asymmetry of our macroscopic reality?
Now, Hossenfelder does mention a couple of potential wrinkles in this time reversibility, right?
Yeah.
Quantum measurement and maybe black hole evaporation.
She does, yeah. But she also points out quite rightly that these are still really complex and hotly debated topics in physics. It's not settled science that they truly break time reversal symmetry in a fundamental way.
So they aren't necessarily get out of jail free cards for the arrow of time?
Not definitively. And even with those potential exceptions, the general idea holds that information isn't actually destroyed in physical processes. It might become scrambled, incredibly difficult to retrieve, like trying to piece together a shattered vase from microscopic dust.
Okay.
But the information about the original vase is still, in principle, present in the fragments and their motion and heat. So if the fundamental laws are largely time reversible, why do we experience this relentless march from past to future?
This feels like the crux of the whole now conundrum. What bridges that gap between a seemingly timeless fundamental reality and our very real, very directional sense of a passing present?
Okay, so the key to understanding our subjective experience, the feeling of a distinct now, appears to lie in two deeply intertwined concepts,
Yeah.
memory and entropy.
Memory. Okay, that clicks on a personal level. I vividly remember the extreme embarrassment of accidentally calling my boss mom that one time. Horrifying. But I have absolutely zero memory of what I'll be having for lunch tomorrow.
Exactly. That asymmetry memories of the past, none of the future, is absolutely fundamental to our perception of time's arrow. Our brains are constantly recording past events, building up this rich tapestry of memories, but we don't have similar records of the future. This
Mhm.
fundamental difference naturally creates a boundary, the present moment, separating the known recorded past from the unknown, unrecorded future.
And Hossenfelder uses this fascinating example, doesn't she, of mica.
Yes, the mineral mica. It can trap traces of past events, like tiny radioactive particles leaving damaged trails within its crystal structure as they decay over millions of years.
So it's like a rock that has memories, a non-living thing possessing a form of memory.
Precisely. It's a physical record of past states. And this leads us directly to entropy. Now, entropy is often described simply as disorder, but it's more precise to think of it as the number of possible microscopic arrangements of particles that correspond to the macroscopic state we observe.
Right, like my sock drawer example. There's basically one way for it to be perfectly organized, but countless ways for it to be a jumbled mess. It always tends towards the mess.
That's a perfect analogy. Chaos is easy, order is hard. And the second law of thermodynamics, one of the pillars of physics, states that the total entropy of an isolated system can only increase over time or stay the same. It never spontaneously decreases.
It always heads towards more possibilities, more messiness.
Towards a state that has more possible microscopic configurations. And this relentless increase in entropy is deeply connected to our experience of time's direction. We perceive the direction of increasing entropy as forward in time because our memories record past states, which, due to the initial low entropy of the universe, were generally states of lower entropy.
Okay, walk me through that again. How does entropy link to memory and forward time?
Think about that glass falling off a table and shattering. The intact glass is a relatively low entropy state. Fewer ways for the atoms to be arranged and still be that glass. The shattered pieces on the floor represent a much higher entropy state, vastly more ways for those atoms and fragments to be arranged.
Got it.
We remember seeing the intact glass before we remember seeing the shattered pieces. We don't remember it the other way around. Our memories encode the sequence that follows the increase in entropy. So the increase in entropy gives us our arrow of time, psychologically speaking, because memory formation itself relies on processes that increase entropy.
Wow. So the past feels before because things were generally more ordered, lower entropy.
According to our records, yes.
And the future feels after because things will likely be in a more disordered, higher entropy state.
Exactly. And it's also crucial to understand, as Hossenfelder points out, that entropy isn't some inherent property of disorder floating around. It's really a measure of our ignorance, our lack of complete information about the precise microscopic details of a system. We don't track every single atom in those shattered glass fragments, so we describe its state using macroscopic properties, which corresponds to a high entropy value.
Okay. Okay. So we've got this subjective feeling of now deeply tied to how our memories work and this relentless increase in entropy. But what about the objective picture, the mathematical description of the universe that physics gives us? Where does the specialness of now fit in there?
And that's the key distinction, isn't it? Between our subjective experience and objective reality, or at least the reality described by physics. While each present moment feels incredibly special to us, it's where we are. It's where new memories are being laid down. There's simply no evidence for an objectively special, universally defined now in the fundamental equations.
Hossenfelder mentions Einstein himself sort of grappling with this, right? This powerful human feeling of the present that seems absent from the physics equations.
Yes, exactly. And the key insight, as the source material really emphasizes, is that this unique feeling, the sense of nowness, most likely arises from our capacity for memory. It seems to be a biological and cognitive phenomenon, a feature of how conscious, memory-forming systems like us interact with the universe, rather than a fundamental property of the universe itself.
So the problem of the now it isn't really a physics problem anymore.
That's the argument. It's perhaps less a puzzle for physics to solve and more a question of understanding how our subjective experience, our consciousness, our memory emerges from and relates to the objective, seemingly timeless nature of the universe described by the mathematics.
Okay. So to try and wrap our heads around this, the now we feel so intensely isn't some special spotlight moving along the timeline of the universe.
It doesn't appear to be, no.
It's more like a construct. Something our minds create, built on the foundation of memory and riding the forward wave of increasing entropy.
That's a really good way to put it. Our perception of now seems to be this fascinating interplay between the fundamental laws of physics, relativity, thermodynamics, oftentimes symmetric at their core, and the very real time asymmetric biological process of forming memories. Physics might reveal a universe where all moments exist in some sense in the block universe picture, but our lived experience is anchored in this seemingly unique present, shaped by our memories of a past that was overall in a state of lower entropy.
It's almost humbling, isn't it, to think that this intensely real now is, in a way, our own personal construct within this vast, timeless universe. Pretty profound stuff.
It really is. And maybe it leaves us with a final thought, something for you to ponder. If our experience of now is so intimately connected to the way we form memories and the relentless increase of entropy we observe, how might different forms of memory,
Like in Aliens or AI.
perhaps, or even just under drastically different physical conditions, maybe near a black hole or the very early universe where entropy behaved differently.
Yeah.
How might that lead to entirely different, maybe even unimaginable perceptions of time and reality?
Whoa.
It's a question that really makes you think about the boundaries of our own experience, doesn't it?